Hello, my name is Edmund Burke, SIL CEO. I'll be presenting the Advanced Power Integrated System Technology today, Solution ID 7489, Intelligent Batteries for Safety Critical Launch Vehicle and Satellite Applications. SIL is a woman-owned small business based out of Santa Maria, California. We're dedicated to space R&D and manufacturing of flight units for DoD prime contractor and federal agencies, including the U.S. Space Force. We are AS9100D quality management system to design, manufacture, and environmentally test our avionics and lithium-ion battery systems. The problem statement we're trying to solve is the Air Force lacks a common lithium-ion intelligent battery that's open, modular, scalable, high energy, and safe to meet multiple DoD battery requirements for different platforms and easily usable by U.S. Space Force airmen. The current fielded silver, zinc, NiCad, and nickel metal hydride, the majority of the DoD launch vehicles, satellites, and aircraft platforms are very low energy density, large size and weight, and they're very difficult to maintain and use. The other issues are you have toxic electrolyte in these batteries, which causes a whole facility needed for them with high labor costs. They're very complex to manufacture, so you need highly skilled labor. And that labor is going away with these batteries, and the material is getting hard to find. Also, they're not very reliable, and there's many missions that get scrubbed, especially on the launch vehicles with silver zinc batteries. The high life cycle costs, also, I already discussed the high maintenance and operation cost. The difference of our technology, key features and benefits, are that it's very high energy and it's a safe lithium-ion battery with advanced BMS built in. The BMS is agnostic to the battery chemistry, and it's firmware programmable for all protection set points and temperature control features. We also have sophisticated prognostic algorithms running, state of charge, state of health, remaining useful life to increase the safety of the lithium battery. The advanced BMS itself within the batteries, very high resolution measurements, voltage and current, 1 millivolt and 1 milliamp. They have protection features all built in. Over voltage, under voltage, short circuit, and temperature protection when you're operating the battery in the lab, testing the subsystems of the launch vehicle or the satellite. We have also a min-max data recorder, just in case the technician didn't see, say, power went down and came back up and the power supply went to 100 volts. It will record that automatically. You also have automatic sleep mode. We designed a BMS so that if there's no load or current, it automatically goes to sleep. It only draws less than 24 microamps. And this cell is very low discharge, can sit for years on the shelf, and with we've measured it less than 2% a month loss, basically, of capacity, and that's better than a lead acid, even with the BMS inside. We also have automatic cell balancing during charge and automatic heater control set points down to -55 Celsius. Other key features are we're using most state-of-the-art lithium-ion polymer NMZ pouch cells from 175 to 250 watt-hour per kilogram energy density. They're very high power too. They can discharge 5C to 30C discharge current. What this enables is us to power not only like a satellite subsystems, but also a very high power payload simultaneously on a satellite. Which most the batteries for satellites can't do that. They can only power the spacecraft and not the high power payload. The battery is totally rechargeable in less than 30 minutes from a 50% dead state on every satellite orbit with a 1C charge current from a solar panel array. It also has the algorithms. Prognostic algorithms detect and flag weak cell, measuring internal resistance prior to going to a thermal runaway event. We also can add the thermal isolation and energy absorption material between the pouch cells to eliminate heat transfer from one cell to the other to stop a thermal runaway event. And we designed the battery to meet all the Air Force SMC 016 lithium battery requirements, the RCC range safety 319, 324, and we've also done NAVC testing, destructive testing at the cell and battery level, and UN 38.3, and the batteries have done exceptionally well to meet all these requirements. Another key feature of our battery is that it has very 3 times the energy density of nickel-based battery, which I discussed, and 2 times the energy density of silver zinc. It has excellent cycle life because of the NMZ chemistry. It does 30,000 cycles at C/2 charge and discharge rate to 20% depth of discharge at 80% capacity for a satellite application. We've also in our patents have shown how we package these cells for extreme thermal cycle and vacuum, shock in 1,000, 2,000 Gs and random vibe and 60 GRMS, and we've been successful at that. We also develop a Windows GUI and data logger, which I'm showing in the next slide, where an airman, uh, U.S. Space Force airman can perform the charge and discharge operation without any problem at all. Here's our GUI and data logger that we provide with each battery. It shows here on the left, all your cell voltages are instantly monitored at the cell level. You can also, during charge, you can see which cells are being balanced. You can see the telemetry messages coming out of the battery. That all the data here can be sent down from a launch vehicle or a satellite as it flies. We show the state of charge. We have the heater control, built-in status. We have critical status bits, which is your charge pathway and your discharge FETs. And if you have an overvoltage condition, like on the charging, and someone actually put 100 volts, the overvoltage protection would immediately show red. Also if you have a short circuit, you would show that immediately and open up like the discharge FET, so you can't in the lab not have a problem. We also have a very special feature called the discharge protection override. You see in red that if you short 2 pins on the cable, this battery will discharge no matter what, and it bypasses the protection features because you have one shot to get to orbit with a launch vehicle, and the battery must deliver. And also when on the satellite, even if there's a subsystem short, the battery has to deliver and the power. Okay, so very easy to use. Air Force, Space Force airmen can work with this battery. Here's our current product line showing the scalability. Every one of these batteries has our BMS in there. It goes from 2 amp hour FTS battery all the way down to 150 amp hour spacecraft battery. I'm very proud to say that the Air Force has made major investments through the SBR Phase 2 and Phase 2 enhancement programs of these batteries. Our flagship product, our 20 amp hour that started us into this in 2011, I'm very proud to say that we successfully flown 16 different missions with this battery, and it's tier level 9 and 100% mission success. Also, some of the new space companies, Firefly and Generation Orbits, decided to go with this battery. And we also have a current contract with NanoRacks, NASA NanoRacks mission. We developed in the smallest, lightest battery ever produced, a 52 amp hour spacecraft battery that it powers not only the spacecraft but also a high power payload that's going to cut a second stage slice in the SpaceX second stage with a metal cutting tool. It draws 180 volts at 10 amps, and we were the only battery that could do this in the nation, enable this mission. Next slide. Our transition partnerships, we want to work directly with the Air Force and Space Force program offices, the DoD prime contractors, and we also are working directly with the commercial space industry, the new space for the launch vehicles and this new small satellites that are coming, revolution that's happening. We can make a major difference and added value in both of those areas. We're very focused on the military transition targets of satellite space launch vehicles, missiles, strike weapons. We're already working with the JASM program office with our 2.1 amp hour FTS battery, and also we think we can add value in hypersonic and reentry vehicles. Here's some additional technical information. Developed a video on our avionics and lithium-ion intelligent batteries. You can watch at these links by clicking on them. And I also recently published a paper on the AIAA 2019 Propulsion Energy Conference. You can read the paper. And also I always present it usually at the NASA Battery Workshop, and I've done that for years. And so this additional information for you you can look into. If you have any questions at all, please feel free to reach out to me via phone or email, or Marty Waldman, our business development director, that also greatly assisted in this presentation. And I appreciate your time and look forward to working with you all to make a difference and add value to batteries and energy to all these different advanced platforms. Thank you very much.